Hello everyone, thank you for joining this training Terraform 0 to Expert. Let us start. These are the objectives which we are going to cover as part of this training. Infrastructure as a code, Terraform purpose, benefits, Terraform lifecycle, Terraform core concept, Terraform installation, how to use Terraform CLI, interact with Terraform modules, navigate Terraform workflows, implement, maintain state, read, generate, modify and configuration, understand Terraform Cloud Enterprise capabilities. So first one is Terraform infrastructure as a code. Here you can write code for code to manage your infra or provision the infra. So infrastructure code is the managing and provisioning of infrastructure through code instead of through manual process. Every and each part of your program is part of your resources. You can put in a script, write the script and write the code for all resources, all settings, security of your infrastructure. With IAC configuration, files are created that contains your infrastructure specification, which makes it easier to add it and distribute configuration. Yeah. So for your services, for your project, for your API, you can write their respective resources, their instances as a part of Terraform script and set their configurations. Then this program will take care to create infrastructure on cloud via this Terraform program. So that is all about infra as a code. Next one is benefit of infra as a code Terraform. It reduces the cost. It is pure automation where you can manage your infra, your security, all resources via code. So it reduces the cost as it is 100% automation. Reduce the error. There is no chances of errors. Most of things are being done by program, not manually. Increase in speed of deployment. Pipeline will do the deployment, run the Terraform script for one environment, for multi-stage environment. So it surely improves the deployment speed. Very easily we can deploy the resources via pipelines. Improve infrastructure consistency, yes. Whatever naming convention standards are being used by the code within the Terraform script, those would be consistent across your environment or multi-stage environment. Wherever you are applying those resources, those would be consistent. Easily portable to other provider, yes. Today I am using for Azure, then I will be using Azure RM and for my all resources. Tomorrow your management is going to decide to move from Azure to AWS. Then with minimum changes you can set up all your pipeline, all infra with AWS or GCP. It supports multiple provider, various AWS, Azure, GCPs mostly being used. Apart from that, Oracle, many other provider which where you can also use those provider as part of your on premises. Provide immutable infrastructure where configuration changes smoothly, yes. Uses easy understand language. Easy to understand the language. SCL is one of the language. ASIC configuration language where you can do all the programming, write your Terraform script, reuse, define reusable component, various things just like other programming language, C has and Python and Java. Same thing you can do here also. Provide immutable infrastructure where configuration changes smoothly done. these all key benefits of Terraform infra as a code. Next is Terraform Lifecycle. 4 commands are important. It's a part of Terraform Lifecycle. Whenever you're writing any script for your microservice, for your API, for your function app, then you need to identify their respective resources, and when you are going to apply them into cloud, then you need to run the script. Then first command would start from the init Terraform initialization. So Terraform initialization is it initializes the state of that service for respective resources, all resources which you mentioned into the configuration file. Second command is execution plan, Terraform plan. It creates the execution plan for new resources, existing resources, or the any change in the existing resources. And this execution plan would apply to actually on cloud vendors, cloud for your resources. So first, initialization of a state, generating the execution plan, and then apply. So apply is which is actually applying on the Azure cloud, where you can see all your resources there, all configuration. And third, last one is destroy. Destroy is something, let's suppose you want to remove your resources from your cloud, then or from the Azure, then you can remove those resources from your configuration. Then it will destroy all those resources which are not part of your script. So important is here, every time it is not recreating the all resources, it is executing the plan and then checking what are the new changes for them, it is applying, and rest it is not touching anything. So this all is part of. Now next one is Terraform core concept. There are some set of core concept or practices which or key point which we need to consider when we are working as a part of Terraform code. So first one is variable. There are two type of variable: input variable, output variable. Input variable, when you want to give something to your script from pipeline or from other places, so those script are taking some inputs, that is managed by an input variable. Output, let's suppose resources created. Now you need to use that resource some other place outside of that state or within the state, or one service resources need to use by other service. Then you can keep set them as a out, which would be available from outside of that state, outside of that service also. So for that purpose, we need to use out variable. Input and out are very important. Mostly you need to use. Apart from that, it is a key value pair. Input variable are used to parameterize to input values at the time of customize or deployment. Output value are return value to the Terraform modules that can be used by the other configuration also. Now provider, as I mentioned that Azure, we use Azure RM. Also for different cloud, there are different providers are available which you need to use. Module again is same, which kind of reusability, where you can create one module and that module can be used to the root module. So one API or one services, we can have at least one root module, and that root module can call rest of other modules which are known as a child module. Suppose for one API or in your project there are 10 API and they need to use the resource group or API instance or various VNet, subnet or DNS, various things. So what you can do, create modules for them and root module can call them. So it is kind of reusability of your code. It reduces the repeatable code. State is key. State can be defined for each service or can be defined some core infra state, which are for common component. So Terraform create store all the infra state in their state file, and whenever we applying anything, then it's comparing with the cloud and ensuring that if any changes, then it's creating execution plan for those changes. So it state play big role. Let's suppose someone is removing your resources from cloud, maybe by mistake or intentionally. Then when you run your pipeline, then whatever is, it finds the gap in cloud and state execution plan, then it will create all resources again. And resources are again, for one service we can have multiple resources, resource service instance, a resource group, and there are various others related to security. So these are the resources which we write them into the Terraform script and would create them onto cloud. Data source. Data source play very good role whenever we want to share the object or resources among the services. Then we can use with the help of data source. It provides a remote data source is also available, and it allows to use the sources of one services inside the other services. Plan is, we already cover, is a part of Terraform Lifecycle. Create execution plan. Apply is command of lifecycle. Last command is apply the your resources into the cloud. So this is part of this video which we covered as a first video. Next we will be covering installation of Terraform and